Truck-mounted pressure vessels are engineered to withstand significant force, yet if they are not completely depressurized, stored potential energy can be instantly converted into extreme kinetic energy. Manually releasing latches before the system equalizes with ambient pressure triggers a sudden, forceful gas discharge, creating dense vapor and unexpected thrust. Maintenance negligence is evident here, as the operator attempted to perform repairs without using pressure gauges to verify that the vessel was empty, while also positioning themselves directly above the tank lid in the highest risk hazard zone. Safe operation requires strictly venting systems through designated valves and verifying pressure levels before opening any components. Personnel must never stand in the direct line of a lid or where they are vulnerable to high pressure releases, and must always wear appropriate protective gear to guard against debris. The incident in the provided video underscores how a lack of logistics automation, such as relying on manual unloading from elevated positions instead of hydraulic dock levelers, create significant operational risks. Deficiencies in safety infrastructure, particularly the absence of floor markings and physical barriers to separate pedestrians from active loading zones, further expose personnel to avoidable hazards. Human factors also play a critical role through the normalization of deviance. Workers may perceive risky, manual methods as efficient, while relentless operational time pressure encourages the bypassing of safety distancing rules, impairing essential coordination. To mitigate these threats, businesses must prioritize engineering controls, investing in mechanical handling equipment to eliminate manual tasks at height. Additionally, data-driven safety management, focusing on analyzing near-miss incidents to refine standard operating procedures, is vital to ensure that engineering processes and awareness remain synchronized to transform workplace culture. Wastewater infrastructure poses invisible hazards, as anaerobic decomposition frequently generates flammable gases like methane and hydrogen sulfide. When these gases concentrate in enclosed spaces without adequate ventilation, they reach explosive limits where even a minor spark, perhaps from non-explosion-proof electrical equipment or metallic friction, can trigger a combustion event. Operational gaps, such as the absence of portable gas detectors or failed forced ventilation, often allow dangerous gas pockets to accumulate at tank floors. To mitigate these systemic risks, facilities must prioritize toxic gas monitoring before entry, install certified explosion-proof equipment, maintain continuous ventilation, and conduct rigorous emergency response training. Relying solely on work experience is insufficient. A structured, strictly enforced risk management process is essential to control these hidden hazards. The incident involving the excavator in Afuji Bexikville Sevroxlothiovko Fuxkin Poekokyegoju 7 Fixki MIP4 highlights the severe risks of loading heavy machinery onto floating platforms without adequate stability. The lack of secure physical connections, such as industrial standard loading ramps and mooring systems, allowed the barge to shift, leading to a catastrophic loss of balance as gravity converted potential energy into kinetic energy. This failure was compounded by a clear disregard for risk assessment and operational protocols, with personnel positioned in hazardous proximity to the equipment. To prevent such failures, it is mandatory to use specialized support equipment to ensure absolute stability and verify the structural integrity of the landing area before initiating any movement. Operators must be trained to respect the physical limits of gravity and buoyancy, as mechanical power cannot compensate for a lack of proper support. Curved roads present significant hazards due to dynamic blind spots, as a truck's structural design limits a driver's field of view, and inappropriate speeds can cause instability leading to collisions. Stopping or gathering near such roadways is extremely risky because individuals often cannot see approaching vehicles. Effective speed management at these curves is critical. Without protective barriers or buffer zones, people in the vicinity have no time to react if a driver loses control. To enhance safety, facilities should implement systemic measures including installing convex mirrors at obscured curves, constructing rigid barriers to separate pedestrians from traffic, strictly prohibiting stopping at hazardous points, and encouraging greater vigilance near roadways. Ultimately, traffic safety requires a combination of skilled driving, secure spatial design, and strict adherence to fundamental positioning and clearance rules. An arc flash occurs when current travels through the air between conductors, often resulting from equipment failure or improper maintenance. During an event, thermal output can reach thousands of degrees Celsius in an instant, creating extreme air pressure and intense heat. Operating on electrical equipment that has not been de-energized is the direct cause of this uncontrolled energy release. The personnel in the video lacked specialized flame-resistant clothing and stood in close proximity to panels without insulating barriers, significantly increasing the risk of becoming unintended conductors. Core safety measures, such as mandatory lockout-tagout principles, are essential to prevent re-energization. Personnel must also evaluate incident energy to determine the appropriate level of protective equipment needed before commencing work. Adhering to these safety procedures is a vital necessity to ensure worker safety. Fuel terminals utilize high-pressure systems to transfer substances, where interfering with components before they are depressurized creates a risk of sudden mechanical energy release. The incident shows how accumulated pressure escaping through a coupling creates a forceful vapor cloud, illustrating the instant conversion of stored potential energy into kinetic energy. Maintenance tasks must strictly adhere to energy isolation protocols, as standing on a vessel without verifying its safe status carries extreme risk. Before any task, personnel must verify actual pressure with instruments, ensure valves operate correctly, and utilize proper PPE to prevent risks from sudden releases.